Today we'll be looking at the introduction to thermodynamics. What is thermodynamics? The word thermo means heat, while dynamics means change or motion. So if you are to define the thermodynamics, we have different ways to define it. We can say thermodynamics is the branch of chemistry concerned with the heat effects that accompany chemical reactions. If you have to look at chemistry, you know that we do react chemicals together. The reaction will take place through a particular medium. So the medium that makes the reaction to take place are what this thermodynamics is working about or talking about. For instance, let's say you want to cook a beans and rice. For the bond that holds the molecules of beans together and the one of rice to be softening for you to eat, then you need to apply temperature heat to dissolve that bond. So the thermodynamics is working on a particular heat that makes that rice and beans to be soft for you to eat easily. Also, pressure also apply in that particular reaction. Now, that is why we say thermodynamics is the branch of chemistry concerned with the heat effects that accompany chemical reactions. What are the terms in thermodynamics? If you're talking about the terms in thermodynamics, we have many. We have system, surrounding, open system, closed system, then isolated, or we say isolation system. Let's look at the definition of each of these system one after the other, or let me say terms one after the other. When we say a system is a part of the universe chosen for study. In thermodynamics, the word system is a part of the universe chosen for study. It can be a large system or small, such as ocean on Earth or a port. For instance, let me just use this an example of a system for you. Let's say you want to cook a soup. You know, the pot that you use to cook that the soup, the pot is the system. If you're in the laboratory that you want to make a reaction, you will need some apparatus like conical flask, like a beaker. Let's say the reaction that you want to prepare, you prepare that reaction inside a beaker. The beaker is a system. So that is why we say it's a part of the universe chosen for study. That is, you use beaker to make your reaction. It can be a large something. It can be a small one. So depending on your system. The next thing is surrounding. The next thing is surrounding. When we say surrounding in thermodynamics, these are part of the, okay, this, I repeated this are in two ways. These are part of the universe outside the system with which the system interacts. For instance, when you have a pot, as I've said before, you know, when you put something inside the pot, okay, okay, you put the soup and everything, you cook the food. The pot will react with the surrounding. How? The surrounding is the outside the pot, in which the heat that your pots are already acquired will be transferred back to the atmosphere. So the atmosphere surrounding the pots is called surrounding in thermodynamics. So the atmosphere where the pot is going to interact to release the heat back to the atmosphere is called surrounding. So that's why we said these are part of the universe outside the system with the system which the system interacts. Then another term is an open system. What we say open systems. Open system is the system that exchange energy and matter with its surroundings. If we are talking about the open systems in thermodynamics, a typical example is that when you want to boil a water, let's say just a pot of water that you want to, let's say you want to bath, and you did not cover the pot, you apply your water, you apply the heat, and your water start boiling. That particular system is called open system. Why? In an open system, there is exchange of two things. There is exchange of energy and matter. The energy will be releasing to the atmosphere, to the surrounding, and the matter will be coming from the surrounding to the pot, that is to the system. For instance, if you are boiling the water, you will see that some vapor or steam will be going out that particular steam or vapor that is going out is refers to energy. Why some particles, you may not be able to see the particle, but keep it in mind, particles are dropping inside the water that you're boiling. So that is the matter. So such particular system is called an open system. Now, a closed system, the next one. This is the system that can exchange energy but not matter with its surrounding. This is like the word sound, closed system. Let me use the same example. Let's say you want to boil water again. Maybe you want to prepare a bar, or let's say any type of food. You cover the pot and you put something inside, maybe water or something, and from there you apply the heat. The matter will not be able to come back to enter the pot because you have already covered the pot. But you can see that vapor will be going out. That vapor, all the steam that is going out is refers to the energy. So one thing is involved here, that this system is going to exchange to the atmosphere, or let me say to the surrounding, which is what? The energy. But the matter will not be able to enter or come into the system. That is why we say a closed system, this is the system that can exchange energy but not matter with its surroundings. Let's look at the fifth terms in thermodynamics, an isolated system. This type of system does not interact with its surrounding, though when you move far in chemistry, it interacts with the surrounding, but it is very slow. It's not as maybe it doesn't interact with the surrounding, but it's very slow. So an isolated system, this is type of system that does not interact with its surrounding. That is, both matter and energy is not going to exchange with the atmosphere or with the surrounding of the system. The typical examples of this one is let me use a vacuum flask as an example. You will discover that when a pregnant woman just gave birth, they need hot water all the time. So there's a material that we call a vacuum flask. The original one of it, when you boil water that's up to 100 degrees Celsius and you pour it inside a vacuum flask, you cover it for a while for about 4 or 5 days, and that water will still be there in the same temperature and be very hot the way you kept the water in the first day. So that particular system is called an isolated system. The vapor will not be able to come out and the matter will not be able to enter. The reaction will not even, the solution that you kept inside that particular system will not be able to leak anything out and nothing will be able to penetrate inside the system. So there's no reaction or interaction between the surrounding and the system. That is what we call an isolated systems. So we are trying to look at all this definition and the terms and all those things that, because in your exam, not this aspect of chemistry is dealing with equations a lot and also with many calculation. But before we can dive into it, you have to know the meaning and definitions of the terms, definition of uh, some types of things that you need to know before you can go into the uh, calculation and the proving of formulas. Also, there's no way we are going to talk about thermodynamics that we not talk about energy, power, and all those things, all others. So energy, that is the ability or capability to do work. Now, what is work? Work is done, or a work is said to be done when a force acts through a distance. From there, we generate the formula of force by saying force is what? Distance. Force. Work is equal to force times distance, or force multiplied by what? Distance. So the energy of moving objects is called kinetic energy. Majorly, you say two types of energy: the one of potential and the one of kinetic. Energy that is in motion, the one we need majorly in this particular course, or let me say topic, is kinetic energy. Energy at motion, energy at change. But when you say potential energy is energy at a static. It doesn't move. When you look at the mango or the orange, unplotted one on the branch, the what hold it or the motion that takes place there is called potential energy. But when you plot the mango, it fell down. By the time it's coming from the branch to the ground, that particular energy is called kinetic energy. Then it has a formula to be half of mass, then v square, which is volume, velocity. Note, the unit of energy, heat and works is in joules. both energy, when you calculate for energy, heat and works in thermodynamics, their units, their SI unit is in joules. But the difference is that heat and work are not forms of energy, but the process, they are like process in which the energy of a system occur or change. For instance, if I apply heat to a particular thing, a reaction is going to form. So um, work has done in that particular place. Abi? Next thing, heat with the heat that I apply makes that reaction to occur. That is why we always put the SI unit for energy, heat and works in joules. Then potential energy, this is the energy at rest. You should know that. Now let's look at the laws of thermodynamics. We have about four laws. We have first law, second law, third law, and also zero law. But I'll be talking about two out of it, the first law and the zero law. If we are talking about the first law of thermodynamics states that, or postulates say that energy can neither created nor destroyed, but it can be transformed from one to another. Yeah, you cannot create energy or destroy energy, but you can, for let's say, you can take a heat energy to a sound energy, mechanic energy to electric energy, those form of energy, you can transform it from one form to another, but you cannot destroy it or create energy. Now, what is this law is trying to explain mathematically, we can say delta E, or we say the E is equal to the Q plus the W. The E there stands for internal energy, the Q stands for the heat, and W stands for work. All these formula, I'm going to prove everything in the next class if I want to explain isothermal reaction. So don't worry about all this formula. I'll just explain them here, and next time we are going to prove each of these formula and solve many questions in, in thermodynamics. Then let's look at zero law of thermodynamics. Zero law of thermodynamics is majorly talking about the temperature of the system. The zeroth law of thermodynamics states that if a system A is in thermal equilibrium with C and system B is also in thermal equilibrium with C, then A and B are also in thermal equilibrium with each other. It's like I have a triangle ABC. If I should say A is equal to B and C is equal to A, definitely my B is equal to C. That is what this law is trying to postulate or to say. For instance, let's say uh, in when you say if something is in equilibrium state, the thermal or the heat of those systems, the three systems ABC, are at a constant position or at equal position. So if A is in thermal equilibrium with C and B is also an thermal equilibrium with C, then A and B are also in thermal equilibrium with each other. That is the what the if you want to remember this law, it's not don't just cram it, just draw a equilateral triangle, put ABC, then relate it. You will see that the law will just flow. Then we also have variables that we use in the thermodynamics. Those variables are very vital, and you must know them from each other, like how to differentiate these variables from each other. We have state variable. This state variable can also be classified into dependent and independent variable. We have extensive and intensive variables, and also we have a state of a variable. When you're talking about a state variable, these are parameters that their values can be determined or dictated. When you say state variable, variables are like the uh, the parameters that we use to represent the systems. For instance, talking about temperature, talking about pressure, talking about volume, talking about the heat, the internal energy, all those things. We use Q for quantity of heat, P for pressure, T for temperature, like that. All those things are variables, which we can determine their values in calculation. So that's what we call state variables. Now, a state variable which depends on other variable is called a dependent variable, while the one which dependent are called independent variables. Now look at this formula of a volume, that is V is equal to nRT over P. In this formula, V, the volume here, is a dependent variable because whatever the value of N, R, T, and P is will tell us what the volume or the V will be. Why others, N, R, T over P, are independent variable. If I should make the P the subject of formula, I'm going to have it to be P is equal to nRT over V. Then at that particular time, P will now be what? Dependent variable. Why nRT over V will now be what? Independent variable. So you should try to know the differences between all these. Then talking about the extensive and intensive variables. An extensive variable, this is a properties of homogeneous system, or let's say it can be homogeneous and also heterogeneous. If it is homogeneous system, extensive variable is one which is dependent on the amount of a phrase in the system. Then if it's for heterogeneous system made up of several phases, because when you say homogeneous, the word homogeneous means same kind, same thing. But heterogeneous is made up of different phases. The total value of extensive property is equal to the sum of all the phases that contributed in that homogeneous to make a particular phase. That's what we refer to extensive variable. In extensive or an intensive property of a phase is depending on the amount of the phase. So thus, refractive index, density, and pressure are intensive properties. Now let's look at the types of process, because there are many processes, or let me say processes in thermodynamics. What do we call a process first? A process means change in at least one of the state variables of the system. When you have a particular variable and there's change in that particular system, or let me say in that particular system, then we say a process has occurred. That is, when the state of a system changes, it is said to have undergone a process. For instance, when you have you have a different boiling point for solvents. Let's say I put water inside the pot and try to apply it. Immediately when I apply the heat, the temperature is going to vary from the beginning to the end. So when the temperature starts changing, you will note this through when you apply the thermometer, then you will see that the change has started occur in that water. Then we can now say process have taken place. So what are the processes that you have, the types of processes that you have in thermodynamics? The first one is isothermal process. The second one is adiabatic process. The third one, isobaric process. The fourth one, isochoric process, and we also have a cyclic process. All these processes, they have their formula, way of using them, how to apply them in life application and also in solving problems. So let's just look at the definition here. Isothermal process here, the temperature of the system remains constant. That is, keep it in mind, in an isothermal process, the temperature is always remain constant. Like the word stand, isothermal. The word iso encapsulated from the word isolation. Thermal means heat. When you isolate the heat, the temperature, that is what we refer to in isothermal process. So when you have a constant temperature, we refer to that particular process as isothermal process. When a system undergoes an isothermal process, it is in thermal contact with a large constant temperature bit known as what? Thermostatic. Adiabatic process. In this case, no heat is allowed to enter or leave a system. Systems in which such processes occur are thermally insulated from the surrounding. That is all about that adiabatic. It's like a isolated system. Then the next one is isobaric process. This is one in which the pressure of system remain of change. When you have a constant pressure or change pressure, it is called isobaric process. Then the next one is called isochoric process. Here, volume of the system remain constant. Thus, a chemical of a constant volume is an isochoric process. So the volume in isobaric process, the volume is constant. Then we have cyclic process. The cyclic process in this case, if the system, after any of the other immediate changes, returns to its original state, the initial and final value of each thermodynamics variable is identical after the completion of the cyclic process. What this one is talking about is like what goes around comes around. A when you have a process that after it has undergo a particular condition, later it comes back to its original position, then we call it a cyclic uh, process. So these are the little uh, terms and the definitions that we need to know in thermodynamics. So in the next class under this, we are going to prove some formula under isothermal and enthalpy and solve many questions for us to apply them in exams. So let's try to uh, know the meaning of, don't just know the meaning, try to understand them, because chemistry doesn't, we don't be, if this aspect of chemistry is very easy because it's calculation and it has formula. You can cram formula, use it to and use it in exam, you know, but chemistry based on understanding. You need to understand what you are doing so that if the question is being filled like you are being twist with the question, you will be able to solve it without problem, especially those who are dealing with molecules like organic chemistry and all that. So you should try to understand the basics things in each steps of the subjects or the topics that you are doing. Thank you for watching the KSA class. Help us to share, subscribe, like, comment, promote our channel. Love you, less.